All right, let's have some problems here involving matrices, probabilities, number systems. Let's start with problem one. A company has two departments. In each department, there are three sections. In each section, there are three accountants, five property consultants, and one receptionist. In one section of a department, two operations managers are also working. And in each section of other department, two clerks are also working. So here we're going to use a matrix notation to find the total number of posts of each kind in all offices taken together in each department, and the total number of posts of each kind in all the sections taken together from both departments by completing the table below. So here I have defined the variables already. AC, these are the accountants. PC, property consultants. R, receptionist. OM, operations managers. CL, the clerks. So these are the positions or the post. And here we have the sections. In each department, there are three sections. This means that ABC belong to department 1, and sections D and F, these belong to department 2. So let's put the numbers here. In every section or each section, there are three accountants. So we're going to put 3 here like so. You can just write 3 once, select the number and drag it down because it's all the same in every section. And 5 property consultants. So 5, select and drag it down. And 1 receptionist. So we select and drag it down. So we are done with the first 3 columns. In every section, we have 3 accountants, we have 5 consultants, property consultants, and 1 receptionist. In one section of a department, 2 operations managers are also working. So you can choose any section, any department. You can write 2 here and the rest will be 0. Basically, you can write 2 anywhere. For example, if you want to put 2 here and 0 there, this one is acceptable because it's not mentioned which department and which section specifically. So we can write 2 anywhere. So assuming I'm going to specify 2 here, that's for section A, department 1. That is easier, you know. But as I said, this can be put anywhere. Let's continue. In each section of other department, so the other department consists of DEF sections because this is the first department. So if the first department contains ABC, the other department consists of DEF. We have 2 clerks are also working. So this is in every section of other department. So we have to specify 2 here, 2 and 2. That's for DAF because every or each section and the rest will be 0. So the table is complete. Let's now calculate the number of posts in every department. So for department 1, that is for sections ABC. So equal sum of these 3 ABC. Enter, select, drag it to the right like so. So these are the answers. For department 2, it's similar. Sum of DAF. Yeah, because these are the sections belonging to department 2. Select the answer, drag it to the right. And both departments equal sum of department 1 and department 2. Select and drag it to the right like so. Okay, so we are done with question 1. Now for question 2, this is about, PMF. P of x here is the probability mass function, or PMF. That means the probabilities for all the events. And we talk about x here as the number of new computers with defects. So we have here 0 defects, 1 defect, 2, and so on until 6. So to calculate the expected number, or we call this as the mean, or the average number of computer with defects, this is expected number. Okay, or we call this as the mean. It's very simple. We have to get the sums of the products here. So basically, if you're going to do this manually, it's gonna be this times the P of x plus the next times the P of x, and we continue until the end. But this can be very lengthy if we have many numbers in a row. So the shortcut is sum product. So just key in sum P and double click sum product. Select the first row, the x values, comma, the P of x. Okay, so our average, or the mean, is 2.46. So this means that most of the time we are receiving 2 to 3 computers, because 2.46 with defects. Okay, so I think that is very clear. Let's proceed to number 3. Number 3 is about number system conversions. Here we have to convert to binary and hexadecimal. The given numbers are octal, 56, and decimal. So basically you can use the decimal or you can use the octal. It's up to you. So if you're going to use the octal, equals OCT to bin, because you are converting from octal to binary. And select the octal. The answer is this. Now you can use any of these numbers to convert to decimal or hexadecimal. So equals decimal, for example, so D is C, to hex. That means you're converting from 46 to hexadecimal. Again, as I said, you can use any of the numbers given. You can use the binary or the octal. So we select the decimal, and the answer is 2E. Here we're going to find the octal and the decimal using any of these two. So for example, I'm going to use the binary, equals bin, bin to octal, to OCT. Select the binary, enter. The answer is 157. Now you can use any of these numbers to convert to decimal. So assuming I'm going to change this octal number to decimal, equals OCT to decimal, because I'm converting to decimal number. So I have to select the octal number because I mentioned here OCT. That means from octal to decimal. So the answer is 111. The last one, you're going to convert to octal number from binary or from decimal or from hexadecimal. So equals, assuming from binary, so bin, bin to octal, so bin to OCT, and I have to select the binary number. Okay, so the answer is 137. Right, so let's proceed to number 4. Number 4 talks about matrices. Here we're going to create a system and matrices for the following problem and solve. I defined the variables already. These variables are coming from the question. If these are not given, you have to define this on your own. So here is mentioned, so go to the question immediately so you can define the variables. Then you can go back to the sentences later. You must report the number of participants for the first course X and the number of participants for the second course Y. How many registered participants for each course? So here X equals the number of participants for the first course and Y is the second course participants. So we talk about number of participants here. So let's read the sentences. So an institute offers 2 professional courses. The first course, which is X, costs $850 per semester, and the second course, Y, costs $999 per semester. At the end of the semester, the institute made a total of $176,698, and the institute had a total of 190 registered participants combined. So there are 190 participants all in all, and these are the participants X and Y. So our first equation will be X plus Y equals 190. So we have to add both of these variables and equals 90 because total number of participants is 190. Next, let's talk about the cost, the money here, the total amount generated. So we have 850 for X. So we multiply 850 times X plus for Y is $999. So 999Y. We don't need to put the dollars, it is understood. Equals the total amount. Total amount is 176,698. So please be careful with the numbers here. One mistake with the digits means all wrong answers. The next is to find the matrices. So we're going to start with matrix A. What we're going to do is just to extract or get all the numerical coefficients, the numbers before the variables. So X plus Y equals 190. It means 1X plus 1Y. So that is 1, 1. Okay. And for the second one, we have 850 and 999. All right. So that's our matrix A. Matrix B. These are the numbers after the equal signs. So we have 190 and we have 176,698. Okay, so let's put our inverse here. Inverse of A. We have 4 numbers. So we need to select 4 cells here and equals MIN. And double click the 5th one, M inverse, and select the elements of matrix A, enter. So this is the inverse of matrix A. And to get the X and Y, we have to write our variables here, and we have to select the cells opposite the variables, and equals MM, M mult, select the inverse, comma, the elements of B, and enter. So these are the values of X and Y. All right, so thank you so much for watching. Until the next time, bye-bye.